So for the study case, we will have four study case. So we will look into one each of the study cases, and there will be some questions related to it, and I will put the study case question on the discussion forum. Okay, whether in the discussion forum or the assignments. Okay, so I will divide it into these two categories. Okay. All right, so these are the learning objectives. So once you finish this chapter, you will learn on how to build new systems to produce the organizational change. And then you will also know the core activities in the system development process. And then the principal methodologies for modeling and designing systems will also taken part in these chapters. And then there are some alternatives methods for building the information system. We will look into that as well. And then the new approaches for the systems building in the digital firms era. Okay, so we'll start with the first study case. It's from Vinci Energy. They built a new mobile employee timesheet apps. Okay, so I will put this study case explanation in different videos. So I will just jump into it's kind of the short explanation about what what the study case was about. Okay. All right. So let's look at these examples about this big company. Okay, it's Vinci Energies. Imagine a company with thousands of workers, like engineers or technicians, who are always out at different construction sites or projects, maybe fixing power lines or building systems in a new office. They have some problems. Okay, their old system for tracking work time was very inconvenient, and manual. Okay, and this means if an employee finish their job at a factory for example, in Taichung, okay, on maybe a particular factory, okay, they couldn't just go home. They couldn't just go home. They had to travel all the way back to their office just to use a computer to type in their working hours and project cost. What a waste of time and energy, is it? So what was the solution? The Vinci Energies, they tried to develop a simple mobile app. It's called the MobiTime. Okay, MobiTime. Okay, it's MobiTime. So MobiTime is like a simple version of the app on your phone. And instead of just going back to the office, an employee can just take out their phone, open the app, and then enter the information right from the job site. Okay, so maybe even while they are still on the bus home, okay, they can do that. So what are the benefits of this the mobile app? It's huge. The benefit is uh, huge. Okay, for the employees, it's faster. It's so much easier. They save a lot of time. Okay, for the managers, the big advantage is that they get the information immediately. This means that the data is accurate and up to date. so they can make much better and faster decisions about their projects than the budgets. So yeah, it's a win-win solutions for everyone. Okay, now let's move to the next uh, part, the next sections of this chapter. And the first learning objectives is about how does building new systems produce organizational change. Well, building a new information system is one kind of planned organizational change. The introduction of the new information system involved much more than just new hardware and software. It also includes change in jobs, skills, management, and organizations. When we design a new information system, we are redesigning the organization. So system builders must understand how a system will affect specific business processes and the organization as a whole. Okay, so let's break this down. This slide, as you can see, is telling us how the technology or IT doesn't just help us to do all things faster. It actually allows the companies to change their whole structure and how they work. Think of it like upgrading from bicycle to a sport car. Yeah, you didn't just go faster, you change the way you travel completely. Okay, so let's start with the automation over here. Okay, automation. This is just using technology to do the repetitive manual tasks for us, like using a calculator instead of counting on your fingers. It makes things more efficient. And then we have the rationalization. So after we automate, we see that some of our old rules and procedures don't make sense anymore. So we streamline them, we make them simpler and better. So it's like organizing the files on your computers so you can find everything instantly instead of just wasting time searching. Right, and then the next level is business process redesign. This is the bigger change. In here, we don't just improve a single procedure. We look at the entire workflow from the start to finish. We asked like, why do we do it all at all? Okay, why we do it this way at all? We eliminate the whole steps that are unnecessary and repetitive, and it's like completely reorganizing your group project workflow to be much more smarter instead of just doing the same inefficient steps a little faster. Okay, and then finally, the biggest change is the paradigm shift. A paradigm is a model or a way of thinking. This is when a company uses the technology to completely redefine what the business is. Think about like Netflix use the internet to change from mailing DVDs to being a streaming service. Yeah, they change the entire business models and the nature of the organizations. Okay, so in summary, the information technology allows the change to happen on these four levels. I'm just doing a test faster to completely transforming the entire company. Right, so let's look at this graph. Okay, it's showing us a very important idea about changing a company. Okay, the relationship between risk and reward. Okay, return. If you want a bigger reward or a bigger success, you usually have to take bigger chance, right? It's the same for businesses. When they use a new technology, okay, on the left side, we have low risk change. Okay. These are things like automation, like using a machine to do the test, and then rationalization, which making a process a little simple. These are safe and easy changes. The good thing is that they probably won't fail. And the bad thing is that the return, okay, the benefits or the money that you get back, okay. The return here is also quite low. It's a small and a safe win, okay. Now, now look at the right side, the high reward, okay, the high reward, the high reward changes. These are the business process redesign, okay. It's completely changing how a whole department works, and the paradigm shift is changing the entire business models, like Netflix moving from DVD to streaming. And these changes can make the company much more successful and profitable. That's the high reward. Okay. But this is the big but. Okay. Um these changes also have a very high risk. They are big, they are expensive and complicated. They can fail completely. So the graph show us this straight up, okay? Severe changes means smaller rewards. The bigger rewards means you have to take the bigger chance, okay? Or you can also mention as a risk, okay? And yeah, the key for managers is the managers need to find the right balance for their company. It's very important concept in this case, okay? All right, so we have another study case from DP World. Okay, so it's the business process redesign from the DP World. Okay, so yeah, you can read the articles, and I will explain it in a simple way for you. Okay, so let's talk about it. Okay, so there's a huge global company called DP World. Okay, it's like uh the managers of many of the world's biggest ports, like the port of Kaohsiung. Okay, and their job is to handle thousands of giant shipping containers every single day. So what was their old problem? The old problems is that their systems was very old fashioned. They use a lot of papers. Okay, they use a lot of papers. For example, if a shipping company arrives, they have to give the same documents to many different departments inside the DP world. This was very slow, inefficient, and caused a lot of confusion, of course. And it's like uh, you have to fill out the same form 5 times for 5 different school offices. It's very annoying, a very waste of time. So they come up with the solutions and the improvement. So the solution was not just to add computers. Instead, they did a complete business process redesign. And this means that they used the new technology, like the cloud software from big companies like IBM, Oracle, to completely change and simplify how the paperwork and information flows. They made everything digital and connected. So What's their main goal? To make the entire global shipping process, which we normally call a supply chain. Okay? They want to make the supply chain faster, cheaper, more predictable, and more secure. So for everyone from the factory owner to the person buying products online, things can arrive more quickly and reliably. It's great examples on how technology can totally transform an old-fashioned industry. All right, so this is the case study question. I will not talking about this question in this uh, lecture video. I will put this three case questions on the iLearning as the discussion topic form. I will put it as the topic discussion form. Then you need to put an answer on that post. Okay. Okay. So let me continue to the next slide. Okay. So let's talk about the business process. Okay. You know, the business process is like a recipe for making your favorite food. For example, like 牛肉面, yeah, beef noodle. So BPM, business process management, is simply the way a company tries to improve its recipes to make them faster, cheaper, and tastier. Okay. And BPM itself is a set of tools and methods. So it's like chefs, knives, and cooking techniques kind of thing. And these methods and tools will help the companies to analyze, to design, and to optimize how they do their work. Okay. So we use BPM when we want to do that big business process redesigns, okay, that we have talked about previously. So how does it work? Actually, it's a cycle of 5 clear steps, okay? It's a cycle of 5 clear steps. It's like following a recipe to improve, okay, uh, your recipe. So first of all, you have to choose which recipe needs improvement, okay? Maybe the noodle making process is too slow, okay? The company picks which process needs a change, okay? And the next one is to analyze. You study the old recipe step by step, and then where are the bottlenecks? Why is it slow? You figure out what's wrong with the current way of doing things. And next, design, okay? Now you create a brand new, better recipe, okay? You simplify the steps, maybe use a new kitchen tool like new technology, and then you remove any unnecessary work. Okay, next, to implement. This is where you actually start cooking with a new recipe. You train everyone to use the new process and you start doing it. The last process is called continuous measurement. Finally, you just don't stop. You always taste the noodles and check if they are good already. A company constantly measure the new process to see if it's really better and find ways to improve it even more. So it's this cycle, it's a never ending cycle of getting better. So BPM is not a one time thing. It's the continuous practice of making a company's recipe more and more efficient. Okay, so now let's look at this concept. This picture is called SIS business process. Okay, so it's like a map. Okay, a map that shows all the steps for how something is done right now before you try to improve it. Okay, so we have the example here is the old-fashioned way of buying a book from a physical store book. Okay, and imagine you want to buy a textbook from a shop near the university. Okay, and this map shows the simple task requires many steps. Okay, for both of you, the customer and the bookstore staff. Okay, for example, you have to first you have to travel to the store. Okay, you have to travel to the store, find the book. Okay, search the shelves, and then you need to book available. Is it the book available? If it's yes, then you purchase the book. Okay, if it's no, then you ask for help from the clerk, from the bookstore staff. Okay, and then okay, so we go to here first, the purchase book. So once you find the book that you want to buy, you go to the cashier, cashier to pay for the book, right? You have to wait in line to pay, and then the staff will have you to check the price, and then you check the money, give your change, and then maybe wrap the book for you. Okay, that's the very manual process. Okay, all right. So this map helps us to see all the tiny steps involved. And then later, when we want to improve things, like designing a website to sell books, we can look at this map and ask which of these steps are unnecessary and which one can we make faster or completely eliminate with technology. So this as SIS process is the first step to making things better. We have to understand how it works now before we can redesign it to be more efficient. Okay, now let's compare this to the old way of buying books. This map, okay, this figure shows the redesign process. This is the new and improved to be process for buying a book online, okay, like Amazon or books.com.tw. You remember all the steps we talked about for the physical bookstore? The traveling, the searching, the waiting in line. This new process use internet technology to remove or automate almost all of those steps. Okay? So now the process is incredibly simple and requires far fewer resources like time and paper. Okay, now you, the customer, just do a few things. Okay? First of all, you access the online bookstore. Okay? And then you search for the book on the website. Click to add it to your chart. Okay? And then pay online. Okay? That's it. While in the background, the website's technology automatically handles the rest. It checks the price, confirm it if it is in the store, if it's in stock, and then process the payments electronically and sends the orders to the warehouse. Okay. So by redesigning the process around new technology, new whole experience becomes faster, becomes easier and much more efficient for everyone. It's a perfect examples of how the business use IT to simplify the complex tasks and save us all time and efforts. Okay, now let's talk about tools, okay, that companies use to do the BPM, the business process management. Remember, the BPM is like a doctor for the company's process. You want to diagnose problems that makes them healthier, okay? But a doctor needs the tools, right? Like a stethoscope or an X-ray machine. And for companies, the tools are the BPM software, okay? It's made by the big tech companies like IBM or Oracle. So what can these software tools actually do? Okay, so we will break this out, okay? Break this down, okay? First, they will help to identify and document. This is like the examinations of the doctors. Okay, the software will help to map out exactly how a process works right now, and then we can find where it's inefficient and messy, and then uh, uh, they will help to create models. Okay, once we know what's wrong, we can use the software to design a new, better model of the process. It's like a drawing a new, efficient blueprint for a building, okay? And then capture and enforce the business rules. It means that the software can be programmed with the company's rules, and then it will automatically manage and perform the new process, making sure that everyone follows the new, better way of working. After that, they integrate existing system. A big company has many different software systems, right? For accounting, for customer records, and etc. The BPM tools can connect them all, so they work smoother to support the new process, right? And finally, they verify and measure. Okay, this is the most important part. After we implement the new process, the software doesn't stop. It continuously checks to see if the new process is actually better. It measures the impact on the key performance indicators like cost, speed, or customer satisfaction. So yeah, so it's like doctors doing a follow-up checkup to see if the patient's really getting better and better. Now let's move on to the next section. So the core activities in the system development process. What are the core activities? Right. Okay, so let's imagine a company has a problem. Maybe their customer data is all messy and they cannot find anything. So we have this, what is called a system development. This is the name for the entire set of steps we follow to build a new software solutions to fix that problem. So it's like the complete recipe for building a new app or computer systems from scratch. We break this big job into 6 main steps. The first is called a system analysis. This is the detective. Okay, it's kind of detective job. Okay, we have to fully understand the problem. what is the current system doing wrong? What do the users actually need? We investigate and define the requirement. Okay? The next one is system design. Now we become the architects. So based on what we have learned, we drew up the blueprint for the new system. How will how will it work? What will it look like? We plan everything out. Okay? And the next one is the programming step. This is where the builders or the programmers take over. They write the actual code to turn the design blueprints into a real working software program. And after that, come up the testing step. So before we use it for real, we have to test everything. We try to find all the bugs and the mistakes. So it's all like chef tasting the food before serving it to the customers to make sure it's perfect. Okay. Next one, the conversion. This is the launching. Okay, launching step. We switch from the old system to the new one. And this can be tricky because we have to move all the old data and train everyone to use the new system. Okay? And the last step is called production and maintenance. After the launching, the system is in a daily use, or we can also call production. But our job is not over. We have to do ongoing maintenance, like updating it, fixing any bugs, making small improvements over time. So the system development is complete step-by-step life cycle for creating a successful and useful information system. Now let's look at this figure. It shows us that building a new software system is not one giant scary test. Okay, and like we previ- we previously discussed, it consists of 6 smaller and manageable core activities, or we can also say steps. Okay, if you build a house, you will not just start building all at once, right? You need to follow a clear process. First, you create the architecture plans, and then you build the foundation, and then the walls, and so on and so on. And this figure is saying the system development uh, consists of 6 main steps, like yeah, which is previously talked about. Okay, the system analysis, how we understand the problems, and then the system design, how we create the blueprint, and then start the programming process, the actual constructions or building, and then testing, checking for any problems, and then the conversion, moving everyone in, and the last one is production and maintenance, living in it and doing repairs. Okay. All right. So let's talk about the very first and most important step in building a new system. It's called the system analysis. Okay. So system analysis is like, yeah, like I said before, it's like being a doctor for a company. Okay. When a company is sick or have a problem, You don't just give it a medicine right away. You have to do a checkup to understand what's wrong, and that's exactly what system analysis is. Okay? So, this system analysis involves a few key things. Okay? First of all, is to define the problems. What is the exact problems? Is the current system too slow? Too expensive? Cannot do what the company needs? We have to find the root cause, not just the symptoms, right? After that, to specifying the solution. Once we know the problem, we start thinking of ways to fix it. Maybe we need a new app or a new database or just to improve the old system. Okay? Next one is to the feasibility study. This is the super important part. We have to ask, um, is this solution actually possible? Uh, it's like, checking if you have enough time and money to build a new house. Do you have, uh, do we have the right technology? Do we have the skills and people to build it? Is it a good investment? Will the benefits be greater than the cost? Kind of things, okay? Now let's talking about the next one is to identify the information requirements. What specific information does the new system needs to handle? For example, if it's for a library, it needs to manage book titles, member IDs, the due dates, right? So we have to list everything in this case. And finally, we have to put all of this research into a system proposal report, right? And this report will explain the problem, looks at different solutions, and recommends the best one. So it's like a doctor doing the report, suggest a treatment for the patients, kind of. Okay. The next one, okay, is to establish the information requirement. So it's like, writing a very detailed shopping list before you go to a supermarket. If your list is wrong, then you will come home with the wrong things, and you won't be able to cook the meals you planned, right? And this is also happens in system analysis. This shopping list is a list of of exactly what information the new system needs to provide. Okay, like who needs the information? Like is it managers? Is it employees? Okay, and then what information do they need? Is it a report or notification? Where and when do they need it? On their phone or every morning? Yeah. Okay. And how? How should it present it? In a chart? In an email? Okay. So this will help us to define the main objectives and detail all the functions the new system must perform. So if we get this requirement analysis wrong, the entire project will likely fail. Okay, so it's very important in this case. So after we finish the analysis, the next step is to system design. Yeah, this is the next step. If the analysis was like creating a detailed wish list for a new car, then design is when the engineers actually draw the blueprints for the car. Okay, so the design phase takes all the functions and needs we to identify and describe how the systems will deliver them. But it's about writing the technical specifications, what kind of database to use, what the screens will look like, and how the data will flow. But it's not just about the technology, okay? A good design must also address the managerial and organizational parts. For example, how will the new system change people's job? What new rules or workflows will be needed? Okay. This leads to the most important part, the role of the end user. Okay. The people will actually use the system every day must be involved in its design. Okay. If you were building a new kitchen for a chef, you will not design without asking them whether they want the stove and the knives, right? It's the same reason, okay, for the software. Their needs drive the entire process. They must have some control over the design to ensure it fits the real world. If the user are not involved enough, the system will likely fail. Why? Because the designers might build something that looks good technically, but is actually difficult or useless for the people who need to use it. So, listening to the user is the key to success. Alright, so this table looks very complicated, right? But actually it's not. It's actually just a very detailed checklist for a system design phase. Okay. It helps the designers to make sure that they don't forget anything important when they are creating the blueprints for the new system. Okay, next, after we finish the detailed design blueprint, the next step is to actually build the system and make sure it works properly. And this stage is called programming and testing. Okay, first talk about programming. This is where the blueprints from the design stage are given to the software developers, the programmers. Okay, their job is to translate those specifications into a language of computers understand, which is code, and then they write all the instructions that will make the system function. So it's like a construction crew builds the house, okay, based on the architectural. But we cannot just build it and start using it right away. We need a testing, right? It's very important. Testing is like quality control to check to ensure the system produces the right result. Okay, and there are different level of testing. Okay, the first level is a unit testing. This is like testing each individual part of car separately, like the engine. We check the brakes, we check the lights, we test each small programs or modules by itself to make it works correctly on its own. And next, the system testing. So after each unit works, we put all the parts together and test the whole system. Does everything works together smooth? Or it's like, you know, taking the whole car to test drive to see that all parts work in harmony. And next one is the acceptance testing. Um, well, actually the accepted testing is to make sure that system is ready to be used in production setting. We test the complete system to make sure it meets the business requirement and is ready for the real world. So it's like, you know, chef taste the final dish before it goes out to the customer. Okay. And the last one is the test plan. All preparation for series of tests. Okay. So test plan is document that prepares everything we need for the series of tests. So programming is about building it. Testing is about making sure it's built correctly and reliably. And this is the simple test plan to test a record change. It looks like a very technical chart, but it's actually very practical. It's called a test plan, okay? Um, no, I just skip that, okay? It's not too important. Now, we got to the most exciting and sometimes a little scary part. It's called conversion. Yeah, conversion. This is the process of switching from the old system to the new one. Yeah, switching from the old system to the new one. So it's like moving from an old apartment to your new house, right? There are four main strategies in this case. The first is the parallel strategy. This is the safest way for a period of time. You run the old system and the new system at the same time. Okay, so you can compare the result to make sure the new one is working perfectly before you turn the old one off. It's safe, but it's also double the work. Yeah, and the second one is called direct cut over. This is the risky big bang approach. On a specific day, you turn the old system off and immediately turn the new system on. It's like moving all your furniture in one day. It's very fast, it's very cheap, but if the new system has a problem, you have a big crisis. Okay. And then the third uh, strategy is called a pilot study. You introduce the new system to only one small group first, okay? Like one department or one office first. You work out all the problems with that small groups, and once it's stable, you roll it out to everyone else. So it's like trying a new recipe on your family before cooking it for a big party. And the last strategy is called phased approach. Okay, so you implement the new system one part at a time. For example, you first install just the new accounting module and later install the sales module. And this will break the big change into smaller, less risky steps. Okay, no matter which strategy you choose, the two things are absolutely essential, which is called end user training and a final documentation. End user training. You must train everyone who will use the new system. If people don't know how to use it, the best system in the world will still fail. Okay? So training is very important. And then about the final documentation. You need to finalize the complete user manual and a technical manual. that explain how the system works for both of the users and the IT support team. So, okay, so conversion is all about planning and managing change carefully to avoid problems in this case. Okay, and the final step, yeah, but actually the job is not over here. The last stage is called production and maintenance, okay? Okay, so in this stage, we'll do a review, sometimes called a post implementation audit. We asked, is the system actually doing what we planned? Is it providing the benefits we expected? And we ask this kind of questions. And this will help us to see if any big revisions are needed. And then we enter the maintenance part. This means that we make changes to the systems to keep it running well and to keep it useful. And this is not about big failure. It's about continuous improvement. And we can break the maintenance work into three parts. Okay, 20% for debugging and emergency work. This is like fixing a flat tire. It's unexpected work to correct errors or problems that pop up after the system is live. And then another 20% for changes to hardware, the software or the reports. We make small changes to the technology or the data to meet the new needs. And the rest, 60% of the work is used for user enhancement, making the system better. Yes, this is the biggest part. We listened to users' new ideas. We improved the instructions, the documentation, and tweaked the code to make the system faster and more powerful. Okay, so maintenance is not a sign of failure. It's a normal and necessary part of the system's life. A good system is never really finished. It always evolves to help the business better and better. Okay, so let's do a quick review. Okay, this table is a perfect summary of the entire system development lifecycle. It shows us the 6 core activities that every IT project must follow to build a successful new system. First one is the system analysis. This is the first step. We try to identify the problems we need to solve, and then we figure out what the new system needs to do and what the information it must handle. The second one is the system design. Now we become the architects. We take the requirements from step one and create the blueprints for the system. We design it how it will work, what it will look like, and what parts it needs. Next one, it's called programming. Here, the software developers take the blueprints and start building. They write the code and turn this design into a real working software application. Next one, the testing. Before we use it for real, we have to check everything. We have to check for any mistakes. We test each small part, okay? Each unit testing, and then test the whole system together. And finally, make sure the users are happy with it. Okay, acceptance testing. The next one is the conversion. This is the go live step. Okay, we switch from the old system to the new one, and this includes the training everyone how to use it and prepare all the instructions manual. Okay, the last one, production and maintenance. So this system is now running, but the job is not over. We have to operate it, check how well it's working, and make improvements over time. Okay, so the technology and the business needs are always changing, so the system needs to change too. Okay, good. Now let's move on to the next section. What are the principal methodologies for modeling and designing systems? All right. Okay, so when we want to build a system, we cannot just start coding randomly, right? We need a clear plan or a methodology, a structured way to create a model or a blueprint for the system. There are two most prominent methodologies. The first one is structured methodologies. The second one is object-oriented development. Okay, so for today, I will just focus on the first one. It's called the structured methodologies. Okay, it's a very traditional and logical approach. Okay, it's a very step-by-step and progressive. You need to complete one step before you move on to the next one. Okay, so this methodology is a process oriented. Okay, it means that it focuses mainly on the actions or the process. Okay, and the key idea is that separates the data from the process. The data, like the customer information or product details, is stored separately. Okay, the process are like the functions that use this data when they need to. Okay, so it's very organized. It's a very linear way of designing system, which is great for projects where the requirements are very clear from the beginning. Okay. Okay. Apart from that, we also have data flow diagram (DFD). So this is like a map that shows the information moves through the system. It's used simple symbols to represent the process, like circles, and then the data flows use arrows, and then the storage use a rectangles. It will help us to see clearly where data comes from, where it goes, and how it gets transformed along the way. Okay, we can start and how it gets transformed along the way. We can start with a simple high-level diagram and then um, break it down into more detailed lower level diagram. Okay. And after that, we have a data dictionary. This is very detailed glossary or list of definitions for all the data used in the system. Um, it explains each data means what types it is. So the number of tags and then where is it used. This is to ensure everyone, the designers, the programmers, the users, has the same understanding of the data. And then we also have the process specification. Okay, it's like a process or some specification to describe the transformation occurring within the lowest level of the data flow diagram. Okay, so it's kind of instruction that describe what happens inside the smallest process shown in the data flow diagram. Okay. And finally, we have a structure chart. This is a top-down chart that shows how all the different parts of the system fit together. It looks like a bit like organization chart, displaying the hierarchy of modules and how they relate to each other. And this will help the programmers to understand the overall structure when they start coding. Okay. And so these all tools, they work together like different types of maps and guides. It will help us design systems that are organized, clear, and efficient. Okay. And these tools will make sure that we don't get lost while building a complex software. Okay, so this is an example of DFD, okay, data flow diagram, and it's like a map that shows how the information moves in a system. The specific examples is for mail and university registration system. So kind of signing up for classes by sending form in the email, not using a website. And the main goal of this diagram is to show where the three big jobs, okay, the process, and then the system has to do kind of things. Yeah, okay, so let's talk about this. The system, first things first, they have the verify availability. The system has to check if the courses you want are actually available. And then the next one is the enrolled student. If the class is open, the system then officially enrolls you in it. It uses your information from the student master file. This is the database of all students, and this is with your new class. And after that, there is a confirm registration. The systems finally send a confirmation letter back to you, the student, to let you know everything is done. And as you can see on the DFD here, there are rows shows the flow of the data, like your course request going in or the confirmation letter going out. The external entity is the student, okay, because the students interact with the systems, but they are out of it, okay, and the data stores are the two databases it uses, the file, course file and the student master file. Okay, so this diagram doesn't show how the system is built with the code, but it perfectly maps out what the system needs to do and where the information comes from and goes to. It's a it's a great tool for making sure we understand the whole process before we start build anything. Okay, everyone, let's look at this chart. This is called a structure chart. It may look like an organization chart for a company, but Instead of people, it shows the different part of modules of a computer system and how they work together. And this specific chart is a high level design for a payroll, okay, for a payroll system. High level means it just shows the biggest, most important part, like looking at a map of Taiwan and then seeing just major cities, not all the small streets. Okay. So the main job here is process payroll, which is like the CEO of the system. And then under the CEO, there are three main uh, departments or modules that reports to it. Okay. First module in this process payment payroll is to get the valid inputs. This module's job is to collect all the necessary information, like uh, how many hours each employee work, and calculate pay. This is the brain. It takes the input and does all the mathematics to figure out how much money each person should get. Okay, next up, the write outputs, the purchase output. This module takes the result and creates the paycheck or sends the information to the bank. Okay, and as you can see here, there are lines. This is to show how these modules call on each other and then pass the data back and forth. So this chart doesn't explain how the calculations are done, but it gives us a perfect overview of all the entire system and how it's organized. It's the blueprint that programmers would follow to start building the system. Okay, now let's talk about different way to design the system. It's called an object-oriented development. This is very popular in modern approach, and this kind of approach, like instead of breaking system down into separate process and data, like the structured methodology does, this method combines them together into a little package called an object. Okay, and an object here is the basic unit. Imagine an object is like a character in the video game. Okay, so let's think of a student object. This student object would combine both the data, like the student's name, ID number, and enrolled courses, and the process itself that can act on the data, like the method called enrolling course or calculate the GPA kind of things. And these processes are called methods. Okay? And a very important rule is that the data inside an object is encapsulated. Okay, this means that the data is like a private diary. The only way to read or change the data is by using the object's own methods. You cannot just reach in and change it directly from outside. This makes the system more secure and organized. Okay, and finally, the objects belongs to a certain class and have feature of that class. So the class is like a blueprint or a category. Okay. For example, the student. Student class is the blueprint that defines what all student objects should look like and what they can do. Then we can have a more specific class like exchange students that inherit all the features from the students class, but can also have its own special data and methods. This is called inheritance. And it saves a lot of time because we don't have to rewrite everything from scratch. Okay? So, in short, object-oriented development is about building system from this smart self-contained object that contained both data and actions, making software easier to manage and to reuse. Okay, now let's look at this figure. It is about a class and inheritance. Okay, so you may a little bit confusing about the words in diagram. There might be a few typos of translation issue, but yeah, it's okay. Just focus on the main data, okay? Think of a class. Class is like a blueprint or a category. Like in this case, okay, I'll give you another example, like vehicles. Okay, vehicles. A class called vehicle. This blueprint defines the feature that all vehicles have, like the wheels, the engine, the ability to move. Okay, and then the inheritance. It means that we can create more specific blueprints based on the general one. Okay, for example, I give you another examples. Okay, the easiest examples. Okay, we have a class called car that inherits from the vehicle. Since car is a type of vehicle, it automatically gets all the feature of the vehicle. Okay, wheels, the engines, but we can do also add special features just for cars, like doors, trunk, yeah. Similarly, we can have another class, like motorcycles in this case, that also inherits from the vehicles, right? It gets the general vehicle features too, but might add its own special features like the handlebars. Okay. So, inheritance lets us reuse the common feature instead of rewriting them again and again. It makes designing systems faster and more organized. Okay, so if we see on this diagram, it will be okay. Just forget it. Okay, so you know the concept, the basic concept of class, inheritance, right? Okay, that's it. That's the most important. So I don't need to um explain about this diagram. Okay, next up. Now let's talk about why object-oriented development is so popular. The key idea is that it's very flexible and efficient compared to the older, more rigid structured way of building systems. Um, you know Lego, right? Lego blocks, okay? With Lego, you can build and take apart and rebuild easily. That's how we mean by iterative and incremental, okay? You develop a little bit, test it, improve it, and add more bit by bit. Okay, it's not one straight line. And now, how does it work in practice? Okay, so let's go back to the object-oriented development concept. In system analysis, we focus on the interactions. We observe how users will use the systems and identify the objects involved. For example, in library system, the object uh, could be the book, the user, or loan. Okay, and then in the design phase, we defined how these objects behave and how they relate to each other. We group them into classes like book class and then subclasses like a book or printed book. Yeah, this is the subclass of the book that can inherit common traits. This is create a clear hierarchy, right? And then during the implementation, that is the actual building, okay? The best part is reusability. You know that many classes like user authentication or date calculation may already exist in the library. You don't have to write them from scratch. You can reuse them or create new ones by inheriting from existing classes. And that's the biggest benefit because you're reusing objects and the code. You can save you can save a lot of time, a lot of money, and you are not rebuilding the same things over and over again. It makes developing complex systems faster and more organized. Okay, so object-oriented development is like smart, efficient Lego building for software. Okay, so is there any other alternative methods for building an information system? Yes, there are. Okay, let's talk about it. Okay, now we have talked previously about the traditional step-by-step way to build a system. But actually, that's not the only way. There are actually several alternative methods to companies can choose from, depending on their needs. Okay? Okay, let's imagine you want to build a house. You don't only have to use the traditional method of hiring an architect and then the builders. You might choose a different way, okay? And there are some main alternatives that you can choose. For examples, first one is called traditional system lifecycle. The prototyping and user development, application software package, and outsourcing. We will talk about this one by one in detail way. Okay. First of all, it's the traditional system life cycle. This is the oldest method for building information system. Okay. Um, and this method is also called a waterfall approach because the yeah, it's literally just like the names, like a waterfall. The process only flows downward. Okay, you cannot go back up easily, and development is divided into clear stages. First, analysis, and then design, and then programming, and so on and so on. It's a very formal division of labor. Okay, and the end users, like the managers of staff, say what they need, and then the IT specialists are the ones who actually go and build it. Okay, and these methods actually puts a big emphasis on formal paperwork, like writing detailed reports and specification at every stage. And actually, this is good because it's very organized and it's still used for building large complex systems like for bank or an airline where you cannot afford mistakes. Okay. And however, however, there's still the downside is that it can be very slow, can be very expensive and inflexible. If you realize you made a mistake in an earlier stage, it's very difficult and costly to go back and change it. It's not very adaptable method for projects that need to be done quickly or might need to change along the way. So it's reliable but not very flexible. Okay, so this is the picture of the traditional system development life cycle. Yeah, as you can see that it shows a very classic step-by-step method for building um, a new information system. Okay, we start from the system analysis and then design, programming, testing, conversion, and production and maintenance. So if you still remember, the terms is like is similar with the previous one, right? We have a cover in this chapter. This is the same, yeah. Where the system analyst, you understand the problems, and then the designs is where you create the blueprint, programming, the actual building, and then testing, the checking for mistakes. The conversion is the moving from the old one to the new system. And then the last one is the production and maintenance, using and maintaining the system. Okay. All right. So next one, next alternative is called prototyping. So this prototyping is much faster and more flexible way to build a system. Um, okay, so imagine if you want to build or you want to design a new chair instead of just spending a long time drawing perfect blueprints, you quickly build a simple model out of cardboard first. You can sit on it, see how it feels, and then change the design easily. So prototyping is like that for software, okay? It's involved building a quick, simple, and inexpensive experimental version of the system, and this preliminary version is called the prototype. Okay, it's not the final product. It's a working model that end user can try out and give feedback on. Okay, and this process is very iterative, meaning that you do it in a repeating cycle. Okay. Uh, we have some steps in this prototyping alternative. First is to identify user requirements, talk to users to understand what they need, and then develop initial prototype, let users try it, and then tells you what they like or don't like, and then to use the prototype, okay, and then after that, revise and enhance the prototype. Uh, this is where you improve the prototype based on their feedback. So once everyone is happy with the prototype, it becomes the template for building the complete system. This method is great because it involves users early, reduce misunderstanding, and save time and money compared to the traditional slow and rigid waterfall method. Okay, it's all about learning by doing and improving step by step. And this is the figure uh, describing how the prototyping process. Okay, so as you remember, the prototyping is like making a quick draft or a rough model of the system. Yeah, just like sketching a drawing before painting the final version. And the goal is just to create something simple and fast so that users can try and give it back early. Okay. And there are some good and bad sides of prototyping. Yeah, that method where we build a quick, simple model of the system first. Okay, the advantage, the good part is it's great. It's useful if some uncertainty in requirements or design solutions. And you know that sometimes users don't know exactly what they want until they see something. This prototyping helps everyone to understand the system better by actually trying it. Okay. And it's often used for end user interface design. Yes, the part of the system that people click and interact with. It's easier to improve the design when users can test it earlier. And it's more likely to fulfill end user requirement because this can make people happier with the result. Because they know what they want, right? And now the disadvantages, okay, the not so good part. Okay. Uh, okay. So first of all, the disadvantages is probably close over essential steps. Okay, like for example, they may not handle a large number of users or a huge amount of data efficiently. And the second disadvantage is may not accommodate large quantities of the data or large number of users. And since the goal is speed, prototyping might skip, some important steps like full testing or complete documentation. And this can cause problem later if the system is not truly checked. And sometimes the focus is so much on making the prototype look good that that essential part, like the security or the data management, they are overlooked. So yeah, we can conclude that prototyping is a very useful method when we want to move fast and involve users in early. But we must be careful not to forget the important technical details, especially when building the large and complex system.
Okay, sometimes building systems from scratch is like very a lot of works, right? It takes too long. Okay, so instead, companies can buy an application software packages. These are ready-made software solutions like Microsoft Office or specialized accounting software. The biggest advantages is that they save a lot of money and time, of course. So why build something if you can just buy it, right? But you cannot just buy the first one you see. You need to evaluate them carefully. When doing system analysis, you should check what features does it offer. Is it flexible? Can it grow with the company? Is it easy to use? What kind of hardware or database does it need? How difficult is it to install and maintain? Is the documentation good or maybe related to a vendor? The company you sell it is reliable or not? Okay. And of course, how much does it cost? Many packages also allows customization. Okay. The feature customization feature. This means that you can tweak the software a little to fit your company's unique needs, like adding your company logo or changing some reports without breaking the whole system. And to choose the best package, company often send a request for proposal to software vendors. This is a detailed list of questions about the software capabilities, cost, and support. So it's like sending a detailed checklist to different company to see which one can make the most fit of your company. Okay. So, using software package is a smart way to get the system running quickly, as long as you choose carefully. And another alternative way to build a system is through an outsourcing. This is a very common strategy in business today. Imagine that your company needs a new software system, but you don't have the experts or the time to build it yourself. Instead of doing it in-house, you can hire an external company to do it for you. And this is called an outsourcing. There are two main types of outsourcing. The first is the domestic outsourcing. So domestic outsourcing here is you hire a company within your own country, and then you usually do it because you need their special skills, resource, or maybe the technology that your company doesn't have. Or offshore outsourcing. You hire a company in another country, and the main reason for this is usually to save money because labor and cost might be lower there. So outsourcing is all about using outside help to get the IT solutions you need, whether it's to access special skills or to reduce the cost. It's a way to get things done faster and often more cheaply, but the company must manage the relationship with the external vendors carefully. And the good and bad sides of the outsourcing, yeah, there's always the good and bad sides of something, right? The first, the advantages, okay, the good part. The biggest advantage is the flexibility. It allows the company to easily get the IT skills and technology it needs, exactly when it needs them, without having to hire full-time employees or buy expensive equipment. So it's like renting a special tool for a short time instead of buying it forever. And then now the disadvantages. Yeah, disadvantages. The not so good part. There can be a hidden cost yet that you don't see at first. Yeah, for example, it takes time and money to find and choose the right vendors, and then the transitioning to the vendors, moving your work over to them. It can be difficult and expensive, and you may also have to share your company's private information with the outside vendors. This can be risky if that information is not kept safe. Okay, so yeah, while outsourcing can save money and add flexibility, companies must be very careful to understand all the possible costs and risks before making a decision. Alright, class, now let's look at this figure. It shows something very important about offshore outsourcing, which means hiring a company in another country to do the IT work. And many companies think that outsourcing will save them a lot of money. But this chart tells us that there are many hidden extra costs that they often forget about. Imagine that a company signed a contract to pay an offshore vendors 10 million. That seems clear, right? But the real total cost is actually much higher. And this chart shows two scenarios. Okay, in the best case, even if everything goes well, the company will still have to pay an extra 15.2% for the hidden cost. Okay, this, and there also that's the 15.2%. It's 1.5 million. So the worst case, if things go badly, like poor communication, low productivity, or high costs to fire local staff, the extra cost could be as high as 57%. Okay, 57%, and that's 5 3.7 million more. So where do these extra costs come from? It could be things like selecting the vendor, figuring out which company to hire, and the transition cost, the time and effort to move work to the new vendor, and then it could be cost for layoffs, the payments to employees who lose their job, okay, and the managing the contract, the time spent managing the relationship, and it could be a travel and communication, like flying to meet the vendors, time zone difference, kind of things. So the big idea is the contract price is not the full price. Companies must be very careful and plan for these hidden costs when they consider offshore outsourcing. Okay. Otherwise, what seems cheap can become very expensive. Alright, so now let's move to the next session. Okay, what are new approaches for system building in the digital firm era? Okay, now let's talk about a faster way to build a software called rapid application development, or we can say RAD. As the name says, the goal is to be rapid, okay, to create a working system very quickly. So instead of spending months or years like in the traditional waterfall method, the RAD tries to build a usable system in much shorter time. So how is it possible? It uses several smart techniques like visual programming and other tools for building graphical user interfaces. So it's like instead of writing long lines of code, developers use tools that let them drag and drop elements to build the user interface. Okay, it's much faster and easier. And the second technique is called the iterative prototyping of the key system elements. Remember the prototyping? The RAD uses this a lot. So developers quickly build a simple version, show it to users, get feedback, and improve it again and again. This cycle repeats until the system is just right. Okay? And the next technique is called automation of program code generation. Some part of the program code can be generated automatically by software tools. And this means that developers don't have to write every single line manually, which is saving a lot of time. And the last technique is called close teamwork among end users and information system specialists. In RAD, end users and the development team work together very closely, and the users give constant feedback and developers make changes immediately. This avoids misunderstandings and ensures the final system really meets user needs. So RAD is all about speed, flexibility, collaboration. It's especially useful when the business needs change quickly and you need the system ready now, not later. The next one, we have JAD. It's Joint Application Design. Okay, so this is a method that helps team work together more efficiently. Imagine you are designing a new product. Instead of talking to users, then talking to designers, and then talking to programmers separately, okay, which can take a long time and cause misunderstandings. So JAD here brings everyone into same room at the same time for a focus meetings. So what is JAD? Okay, so JAD is a special workshop where the end users, the people who will use the system, and the IT specialists, the people who will build the system, sit together to discuss and design the system. They work interactively to quickly agree on what the system should do and how it should work. And the main goal of JAD are first, to speed up the process of understanding what the users need, and to create an initial design for the system much faster than traditional methods. Because everyone is communicating directly, decisions can be made quickly, and misunderstandings can be reduced, and users feel more involved in this case. And this helps make sure the final system really meets their needs. So, JAD is a teamwork accelerator. It helps to get the design right faster by getting all the information, important people to collaborate intensely. Next up, okay, this is a very popular and modern way to develop software. It's called an agile development. Okay, the word agile means to move quickly and easily, and that's exactly the goal of this approach. So instead of trying to build one big, complicated system all at once, which can be taking years, the agile breaks the big project down into many small sub-projects, and each sub-project is like a mini project and can be completed in short time. Okay, short time, usually a few weeks. And each small sub-project goes through a cycle of planning, designing, building, and testing. After each cycle, the team shows a working piece of software to the users and then gather feedback and then improves it in the next cycle, and this is called an iteration. Okay, and the key part of the agile is the communication. It emphasizes the face-to-face conversation between developers and the users rather than relying only on long documents. This will help everyone to understand each other better, make decisions faster, and adapt quickly to changes. So, agile is like building a bicycle piece by piece. You start with the frame and then add the wheels, then brakes, testing and improving at each step. Rather than trying to build the whole bicycle at once without knowing how it works, if it works or not. This kind of technique, it's flexible, collaborative, and perfect for projects where needs might change quickly. And then we have another one. Let's talk about DevOps, okay, development and operations. It combines two words, development and operations. This is very important ideas in modern software development. And the development is the people who write the code, and the operation here means that the people who run and maintain the software on servers. In many traditional companies, the development team and the operation team don't work closely together, and this causes problems like when developers create software that is difficult to run or maintain. And DevOps is a culture that promotes close collaboration between the teams that create software and the teams that run and maintain it. Okay, it's by working together they can create software that is not only functional but also easier to deploy, run, and monitor. It will give two big benefits. Okay, the companies can update their software more quickly, and there will be fewer errors and problems occur when the software is released. So yeah, DevOps is all about breaking down barriers between teams to deliver better software faster and more reliable. It's culture of collaboration, automation, and continuous improvement. Next up, it's one of the modern and popular way to build software. It's called low code or no code development. Yeah. So imagine if you want to build a simple app or a website, but you don't know how to write a computer code, right? Yeah. Maybe some of you don't know how to code. Yeah. No. And most of the people with a low code or no code platform, you might not need to. And these are tools that let people create application using the visual, just drag and drop interface. Okay. And this low code is much more faster. It's designed to help the developers to work faster, and they still write some code for complex part, but they can use pre-built components to speed up the process. And the no-code platforms are even simpler. It allows the non-programmers, like business people or teachers or designers, to build the simple apps by themselves. Okay. However, there are some downsides. The apps built this way can be limited in what they can do, and they might be hard to customize in a special way. And if not managed carefully, they could create a security risk because people without deep technical knowledge are building them. So low code and no code development is like using a template to make a poster instead of drawing it from scratch. So it's quick and easy, but may not be as unique or powerful as the custom-made solution. And it's great for simple tasks, but complex systems still need traditional coding. And then the last one, it's called mobile application development. It's basically about creating those apps you use every day on your phones and tablets, and like Instagram, Line, TikTok, your banking app, and someone might have to build it from scratch. Now there are different ways to do this, okay? And then you can make mobile websites. They are like regular websites but designed to work well on your phone's browser. Then they are mobile web apps. These feel more like a real app but still run in your browser. So it's kind of like Google Docs works. Okay. And the coolest one are the native apps. Okay, native apps. These are built specially for either iPhone, iOS, or Android, which is why they usually run super smoothly and can access your camera, GPS, and all those phone features. And when the developers create these apps, they have to think about special stuff like smaller screens, how people tap and swipe instead of clicking, and then the fact that phones don't have as much memory or processing power as computer. And also they have responsive web design. It's basically just making sure everything looks good, whether you're holding your phone vertically or horizontally. It's like being a digital architect, but instead of building, you're designing experiences that millions of people might use every single day. All right, so we come up with I think I just skip this. Okay, and okay, so this is the case study that I will pick and put in the discussion topic. as this chapter topic. So you can just go to the discussion forum and post your answer. Okay, I have write these questions and you can answers directly on that topic. Okay, everyone, I think that's all for this chapter. It's very quite long chapters, and I will and I will see you in the next chapter. Okay, chapter 14. Okay, see you. Bye bye.